Okay, so in today's class, we will be discussing chapter number 10, which is the last chapter of paper 2. So the name of the chapter is Boolean logic or logic gates. There are two names given to this, but you don't need to feel confused. So first of all, I'm going to explain you what does it means by logic gates or what is the concept of uh, these logic gates. So if I just start the lesson with the basic example of a switchboard right here. Yes. So, Mr. Ryan, can you tell me, like right here, you have two options. Can you explain me what is the purpose of this switchboard?
Sir, to turn on the light
Okay.
or turn on a fan.
Okay. And what option do this switchboard have?
Sir, we can
The switchboard
it
have option like if you press it on, like it is
yes
going
on
to
and
on.
off,
Yes, one
one and
will be
zeros,
one. And if you press it off, it will be zero, right?
zero. Yes,
Electronic circuits in computers. I mean to say all electronic circuits in the computer system. That means all of them. That even includes your solid state drive as well, other devices as well, hard disk drive as well, software is as only hardware as well. All of these electronic circuits are created made up of thousands of logic gates. Softwares are not included in this because they are programmed, but if I tell you about all type of hardware or all type of electronic circuits, they are created out of logic gates. So it's not most likely if I'm going to refer in terms of a computer system. So you can say that, sir, these computer systems or even the laptops as well, these all are basically some examples of your electronic systems, right? And right here, this switchboard is also an example of an electronic switch system. That means that when you are controlling the flow of electric current, when you are controlling the flow of electric current, it is known as an electronic circuit, and all electronic circuits are created out of thousands of logic gates. Do you have any confusion in this statement?
no, sir.
Now, why logic gates? Why logic gates? Because they control flow of electric current, and they control it by this way. They take binary input and produce a binary output, which means that they are going to take as an input some values, and in return, they are going to generate your specific output. So it means like you are giving any binary input. When I mean to say binary, binary means like one or zero, right? You only have two options. So whenever you are giving the input, that means that you only are giving one and zero, but it is generating an output. Now, how the output is being generated, we are going to discuss this into later on into our chapter. But the basic concept is that whenever you have electronic circuits, let it be motherboard, let it be anything, let it be television, it always involves the use of logic gates. Why logic gates? Because they are responsible for controlling your electric current, for controlling your electric mechanism. Like these, all of them are basically some illustrations and some examples of your logic gates, that how the electric current is flowing from one place to another. So are you getting the concept?
Yes, sir.
So several logic gates are combined together to form a logic circuit, and then these circuits are designed to carry out specific functions, which means that we are going to study different types of logic gates, and then we are going to combine them, and that's how it is going to work. Now the table which is going to display the results, or the table which is going to show you the outputs, or the table which is going to show you the desired list of values, it is going to be known as a truth table. We call this Boolean algebra because when we consider the function and roles of logic gates or logic circuits, so Boolean algebra is basically a way to write them. It's like writing or seeing many logic gates, and when you are writing them, so we use Boolean algebra. So they are also known as Boolean logic or logic gates. Now this was the concept. Now these are the 6 gates I have right here, which is a NOT gate, AND gate, OR gate, NAND gate, NOR gate, XOR gate, and one by one now I am going to discuss each one with you. So first of all, let's discuss the concept of truth tables. Then we are going to start the discussion of each and every logic gate. So what is a truth table? Truth table can be known as a table where you can trace the outputs from a logic gate or a logic circuit. It's like a table where you can calculate all your values. It's a table where you can show all of your logic gates, their values, and you can produce a result. Like the same way, when you need an algorithm or when you need a pseudocode, you go to the editor or you go to the compiler. Similarly, when you want to test the logic gate, when you want to test the logic, when you want to test the logic gate, so you are going to use a truth table, because as I said earlier, that in the logic gates it is going to take binary output and produce a binary output. So the question is going to be at which part the binary output is going to be it is going to be saved, and at which part the binary output is going to be produced. Like there should be a sort of chart, or there should be a sort of working area where I can show you this, that from where the binary inputs are being taken and from where the outputs are being produced. So this is the place where you can see them. These are truth tables. So a truth table is like divided into 3 or more areas. Like right here, you can see 4 inputs, then you can see 8 inputs, and this one is for 16 and 16 inputs, right? So you can basically see that this is basically 0, 0, 1, 1, 0, 1, 0, 1. So these values of the inputs are same. They are never changed. Like in the first row, it's always going to be 2 0 2 1, and in the second row, it's always going to be 1 0 and 1 1 if the number of inputs you have taken is 2. And yes, if the number of inputs you have taken is 2, so this is going to start from 2 0 2 1 1 0 1 1. It will remain same. And if the number of inputs you have taken is 3, so this is going to be changed into 4 parts, like 4 0 4 1, 2 0 2 1, 1 0 1 1. And similarly, if you take it up to 16, so this is going to be 8 0 8 1, then 4 0 4 1, 2 0 2 1, and then 1 0 1 1. So this is basically the progression. These values are not like come from somewhere, they are just the input values that remain same throughout your question. Like in your exam, if you are given only 2 inputs, then you will be using this table. That means you, if you are given only 2 inputs, then you will be using only two zeros, 2 1 1 0 1 1. If you are using 3 inputs, then you will be using 4 zeros 4 1. If you have 4 inputs, then you will be using this one. So do you have any confusion in this?
Clear, sir.
Clear?
Yes, clear.
These values basically depend on the number of inputs you have. You just need to remember, if you have 2 inputs, 2 0 2 1, 1 0 1 1. If you have 3 inputs, then 4 0 4 1, 2 0 2 1, 1 0 1 1. And if you have 4 inputs, then 8 0 8 1, 4 0 4 1, 2 0 2 1, and 1 0 1 1. Now I'm going to start the lesson for the logic gates. Can you please bring a paper and pen?
Yes, I already have here.
Now you are going to give the title for logic gates on the top of the page.
Okay, done, sir.
Then the next title is going to be not gate, and you are going to create this table as it is. Make sure you are drawing it correct. If you don't draw it correctly, you will not be getting the marks. I mean, your lines should be straight and it should be like the way it is right here. Like you can see that the input, what is the input? Input is A. From this part, the input is being generated. Where is the output? The output is right here. The output is X, right? This
Yes,
is your input and this is your output. Now you have to see this is a NOT gate. Now write anywhere near this table that NOT gate. NOT gate means inverse. So you will not forget that. NOT gate means inverse.
okay, done.
Now, as you can see right here on the truth table, input was 1. So if I gave the value of 0, what will be the output?
1,
If I gave the value of 1, what will be the output?
0,
Because this is a,
inverse.
and this is the diagram. So if you have a NOT gate and if you only have one input, so that means your output is going to be the inverse of that. So create this table right below this and then tell me, then I'll go ahead. And also write this as well. X is equals to A bar. This A bar is known as an inverse in Boolean algebra.
Done, sir.
Now after that, the second logic gate that I have right here is an AND gate, this one. So now you can see that the number of inputs I have here is 2. This is input 1, this is input 2, and the output that is being generated is right here. And this is your logic gate. So if you have two inputs, I told you in the truth table that you are going to have two zeros and two ones, and 1 0 and 1 1 in terms of the values of A and B. Then you need to write anywhere near this table that AND gate means multiply. Now 0 multiplied by 0. What is the answer?
0,
0 multiplied by 1 is
0,
1 multiplied by 0 is
0,
1 multiplied by 1 is
1.
good. Now you need to complete this part.
Done, sir.
Done with the truth table as well.
Yes,
The diagram, right? Okay.
yes.
Now let's discuss the third gate. The third gate right here is basically an example of an OR gate. So OR gate is like used like this is the gate. You need to draw this. This is the number of inputs. So the easy name for an OR gate is addition. Like you need to add both of them, but this is going to be a binary addition. So you cannot write two or three. The answer is only going to be among 0 and 1 because this is in binary. So if I add 0 and 0, what is the answer?
0,
If I add 0 and 1, what is the answer?
1,
If I add 1 and 0, what is the answer?
1.
And if I add 1 and 1, that is 2 in binary, but we are working in binary, so the answer is going to be 1. So this is for the OR part.
Done, sir.
After this, I have the NAND gate. Now you need to figure it out that what is the function of a NAND gate. Hmm?
Sir, it looks like when the value is high, it's 0, and when the value is low, it's 1.
The answer is right in the name, NAND gate. The answer is even written on the screen as well.
Okay, okay, I understand.
What is this?
If um, if the input A and B are not 1, so the output will be 1.
No,
If they
no,
both are
man.
1,
Listen, this is a NAND gate. If I break it down, what is this?
and
And what is this?
and
No, this is
not
N. Yes. This means that this is basically a combination of not and.
a- and gate.
Yes, that makes it.
Also multiply and inverse.
Yes, 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 exactly. So this is going to be your number of inputs. And now listen here. Not and. Yaad rakhna. So what happens in and? That means inverse plus multiplication, right? Because this
Yes,
is not and. So 0 multiplied by 0. What is the answer?
0,
And make it inverse.
1,
Good. Then I have 0 multiplied by 1. What is the answer?
0,
Inverse.
1,
1 multiplied by 0. What is the answer?
0,
Inverse.
1,
1 multiplied by 1. What is the answer?
1,
Inverse.
0.
You got it.
Yes.
Now draw this as well. The diagram and the truth table.
Done, sir.
After that, we have the NOT gate, NOR gate, sorry. So now can you tell me what does this gate means? This is a NOR gate.
It will be inverse and addition.
Yes, excellent. Because this is a NOR gate. So that means this is not plus or, right? Which means this means inverse and add. So this is the diagram. Let's check the truth table. Uh, 0 and 0. If you add them together, what will be the answer?
0,
Inverse.
1,
0 and 1. What is the addition answer?
1,
Inverse.
0.
1 and 0. What is the answer?
We'll get 1,
1 but inverse.
0,
1 and 1. Answer will be 1 but inverse.
0.
Now complete this.
Done, sir.
After this is the last gate, which is XOR gate. And you are going to draw this gate and write this statement, what I am writing right here. The outputs is only true. The output is only true when the inputs are opposite of each other. I mean to say that when the inputs are opposite, like for example, the inputs are 1 and 0, they are opposite of each other. Or when the inputs are 0 or 1, when they are opposite of each other, only then the output is going to be true. That means the output is going to be 1 only in this condition. Are you getting it?
Yes,
Now check the truth. Let's check the truth table. If I have 0 and 0, is it opposite or same?
it seems so 0,
Yeah, it will be 0. If it is 0 and 1, this is opposite. So this will be 1. If it
1,
is 1 and 0, it will be opposite. So this will be 1. And if it is 1 and 1, as it is same, it will be 0.
0.
Please draw this as well.
Done, sir.
Now we are done with all examples of logic gates and Boolean expressions. And even before I move on to onto the questions, I want you to like at home once again review all the diagrams one by one and their functions, because when I'm going to take you onto the past paper, the diagrams are going to be mixed with each other. It's like they are going to combine three or more diagrams together, where you need to draw the logic gate, which I'm going to discuss with you, and you need to draw the truth table as well. So I want you to at home go through these logic gates once again as regards with their diagram and their truth table, and send me the picture of the diagrams that you have created, so I can check that if you have done any mistake or not.